Welcome everyone, welcome to our channel. Today we are not only talk about a very interesting topic concerning the theory of probability we have studied earlier in our courses, but we will introduce and have an actual and real application of the convolution formula delivered by the normal approximate by motivating the introduction of the central limit theorem. Don't worry, we know it sounds a little bit confusing, but as the video goes on, we will make sure you learn as much as we learn. First of all, as you know, one of the main focus in Mexican culture besides the music, gastronomic and cultural events are the fairground games. The inevitable and unpredictable change and randomness this game produces allow the gamers to feel the uncertainty but also the possibility to win. But you wonder what happens when chance is not random or predictable enough?
An impossible game to play. Imagine you are in one of the most famous fairs in Mexico. Let us say, for example, La Feria de Santa Rita in Chihuahua. And suppose you enter to a game where they offer you the chance of winning a trip vacation to Cancun if you manage to roll 8 dice. For each roll, the sum will lead you to earn points, which each value will correspond to a determined position in this board. To enter the game, it is extremely necessary to pay a fee of 200 pesos for each time you wish to roll the dice. The points in each roll of dice will accumulate. If you get a sum of 28, your fee will double. The boxes containing a star grant 5 points. The boxes containing a circle grant 3 points. The boxes containing red squares remove a point. But as soon as you get 28 points, these boxes will remove you a single point. After a few trials, you end up with no vacation to Cancun and with no money at all. How has this happened? Follow us to understand the trick behind the game. But remember that the purpose of this video is to try to understand and give a lesson on these misuses of mathematics applied in a malevolent way. First of all, we will start by explaining some basic intuitions concerned with the calculus of the corresponding probabilities for independent events. Suppose you would like to know what is the probability of obtaining 5 by rolling 2 dice. For you to understand it better, we would like to illustrate it as follows. As you can see in the image, you are going to have 2 dice, the value, the probability, the sum values, and the sum probabilities. Please note that indeed, the probability of obtaining 5 when rolling 2 dice is of 4/36. For it is the sum of the probabilities of the possible outcomes 1/4, 2/3, 3/2, 4/1, and so on.
Given this intuition, now is the perfect time to introduce the convolution method for 2 or more independent random variables. For this, we will use a worksheet program in Excel to illustrate it better. We start by typing the possible outcomes and their corresponding probabilities of rolling 2 dice and also the feasible outcomes of the sum. Then, we compute the probability of getting a 2 and the probability of getting a 1 in each die and multiply them. This is because the random variable corresponding to the first die and the random variable corresponding to the second die are independent. Note that the calculus of the previous probabilities is given by the famous convolution formula. For example, if we are aiming to obtain the probability that the sum of the roll of a fair 2 die is 3, then it's given by the probability of x1 plus x2 equals 3 is equal to the probability of x1 equals 1 times the probability of x2 equals 2 plus the probability of x1 equals 2 times the probability of x2 equals 1. Computing these entries might be very extensive and exhausting. That is why we are going to use a program built in Microsoft Excel in Visual Basic to implement a function, where range 1 and range 2 are a couple of two-dimensional arrays where the entries represent the support of each random variable and the probabilities respectively.
Given that public function we have created, now we can proceed to calculate the probability of the sum from x1 up to xk equals w, for k equals 4, 8, and 10. Let us remember that the convolution procedure has the characteristic of being recursive, meaning that it defines a term of sequence using preceding terms. A recursive formula must always state the initial term or terms of the sequence. Given the previous calculations, now we will show the corresponding histograms. The first one is a triangular distribution of two dice. As we can see, number 7 has more probability than the others, and numbers 2 and 12 have less probability. The second one is the distribution of 4 dice that is also triangular, where the number 14 has more probability than the others, and numbers 4 and 24 have less probability. The third and fourth histograms have also triangular distribution with 28 and 35 with more probability respectively. Numbers 8 and 42 from the third have less probability, and numbers 10 and 60 from the fourth have less probability than the others. Once compute those examples, let us note that effectively they have a similar behavior, and that as the number of dice increases, the mass function histogram has a better bell-shaped behavior, very similar to the normal distribution. This particular observation allows us to denote that the most centered values of the support have a higher probability of occurring, while those located on the tails have a lower probability of occurring. So, what was the whole case of explaining all this if all you wanted to know is how you got tricked in Chihuahua? Well, now that we have mentioned this process and introduced the convolution formula and taken into consideration the 8 dice example, let us notice that the values on the board that grant points, which are the boxes containing the stars and the circles, are the ones with the smaller probability of obtaining those results. The values on the board that take out points, which are the red squares, are the ones with a higher probability of occurring. And just in the center of the board, where you can find the sum of 28, where the phi will double, implies that it has a higher frequency of occurring. Considering these previous observations, the role that chance or randomness played wasn't just mere luck, but a well-hidden swindle.
The bell-shaped behavior we have seen in the past examples responds fundamentally to the heuristic of what we call the central limit theorem, which states that if you have a population with mean mu and a standard deviation of sigma, and take a sufficiently large random samples from the population with replacement, then the distribution of the sample means will be approximately normally distributed. Let x1, x2, a sequence of independent and identically distributed random variables with an overall mean mu and a finite variance of sigma squared, and let x of n be the sample mean. Then the limited form of the distribution is given by z, which equals the limit when n tends to infinity of the square root of n multiplied by the sample mean minus mu divided by sigma, and that is the standard normal distribution. In other words, if the sum of independent and identically distributed random variables tends to infinity with an overall mean and a finite variance, then it has a normal distribution with parameters n multiplied by mu, comma, n multiplied by the square root of n multiplied by sigma.
It is evidently that indeed the distribution converges, for as far as we know, the roll of a fair die follows a discrete uniform distribution, for the probability of obtaining one simple result is 1 out of 6. So for instance, the mean would be 3.5 and the variance would be 35 out of 12. For you to understand it better, we will illustrate how we did it. With the help of the norm distribution function in Excel, we computed as follows. And these were the following results.
It is possible to observe that indeed by using the CLT we can get a greater approximation of how the behavior obtained from the convolution formula is very well and normally distributed. Knowing that the CLT allows us to generate similar results by identifying the corresponding parameters, n, mu, and sigma greater than 0. Thank you so much for watching this video. We hope it was of great use because we have presented the case of a common scam in Latin America, and we have mentioned why it is completely normal implementing these types of game where the bad use of mathematics has been part of it. We also present the convolution formula and made a great effort of implementing some previous knowledge of probability 1, such as the normal distribution and the central limit theorem. Remember to always look for ways to apply your mathematical knowledge in search of good.